Hello, I'm Bob Finch with Select Spectrum, and I want to thank you all for attending here today. Um, Pleased to see a good turnout on this first day of IWCE. We have a panel session. We're talking about smart use cases for NB-IoT, and would encourage, at least during my presentation, please feel free to ask questions. I'll introduce myself briefly. I've been in the spectrum business, some people say selling air, for, more than 20 years. Initially with WorldCom and Sprint Nextel on the acquisition side, so I've been on the side of acquiring spectrum, and then for the last 15 years on the side of marketing spectrum mostly and providing consulting services. What we're going to do is it's panel session. I'll go first, followed by Christabel and then Jay. We'll each introduce ourselves as we go. I do have a question maybe for the group. If we could have a show of hands here, how many are involved in metropolitan networks for public safety or city uses? One. Okay, good. Two, maybe over here. How about anyone on the utility critical infrastructure side? How many are managing those kinds of systems? Not many. And then how about manufacturers and consultants? Okay. Hopefully everybody's in the right room to learn about these interesting applications. And yeah, we'll take from there. So I mentioned my background at Select Spectrum. We do work with a variety of folks in critical infrastructure, especially also public safety, and helping to supply the spectrum that they need to manage the networks. It's the right to transmit radio frequencies, and we generally work in licensed spectrum. But in this presentation, I'll talk about unlicensed spectrum as well. But really, I won't focus that much on the spectrum. If you want to know more, I'm in booth 2635. I can take you through that. But I think the interest in this room might be more on how are these licenses used? What is the capabilities that we're trying to build? How can we make our cities better? How can we make our country cleaner and more green? And it turns out this is a huge business, and it's a huge opportunity, both from a commercial perspective and just from improving quality of life. So we call this Internet of Things, or sometimes you'll hear Industrial Internet of Things type applications. I'll talk about a couple applications just to give examples. Christabel will talk about others. Jay is going to focus a little bit more on the networks. And hopefully this brings all together a big picture of the kinds of capabilities that are out there. The research here shows a network growing by 24% compounded annually. That's big rates of growth, and reaching almost $7 trillion in the US over the next several years through 2030. So big opportunity here. This is taking a wide range of consumer applications, business applications, governmental applications, public safety. So we see big opportunities. Some examples on the public safety. Do you know where your people are? Are they fully GPS tracked? Are there health monitors? These are the kinds of capabilities that can be built in to protecting our first responders. In terms of, I live in the Washington, D.C. area. They have gunshot sensors that will identify locations where those occur and, warn the first responders where and what happened and how long ago, and really give them a chance to help improve the safety of our city. So significant opportunities there. We work a lot with utilities. So utilities are providing a wide range of services, obviously the electric utilities and others critical to how we live our lives. We certainly notice when those kinds of capabilities disappear. They have both safety, health impacts, as well as commercial impacts. And by monitoring and controlling those networks more carefully, by having the ability to communicate with all kinds of devices all the way out to the meter at the intermediate points, allows those systems to run more efficiently, more reliably, reduce downtime, and also reduce the total amount of greenhouse gases being generated. And then running our cities more safely. This is the particular application that I'm going to talk about next, is on the smart city side. So with regard to smart cities, one of the biggest applications is in smart streetlights. And if you think about it, replacing existing streetlights, there are power savings just from going to more efficient lights. The ability to dim or raise the power, if there's an emergency going on, raise the power, later at night, dim the streetlights, all of that can contribute significantly to savings. We looked at an example of a city with 500,000 people. By implementing a smart streetlight system, and this would typically involve control over a wireless system and monitoring through a wireless system, that city could save $109 million over the life of over the 15-year life of those cities. If that's expanded annually or nationally, there's not only a cost savings, but also a greenhouse gas advance estimated on the total of almost 15 million tons of CO2 on an annual basis. So here's an example application. You can do parking, you can do traffic control, and our general view is that as these applications go into place, you'll be able to build one application over the other, making the city a better place to live, safer, and more efficient and greener. As I mentioned, I'm in the spectrum business, so most of these systems will require wireless communications. We're all familiar with Wi-Fi. That's an unlicensed system. It generally works pretty well, but there are interference issues, and if you're establishing a system on a citywide basis, I'd encourage you to also look at what the advantages would be to step up to licensed type operations. This intermediate level, we'll call it CBRS. These are managed systems, but it's still shared spectrum. And so while you can have better use of the spectrum, higher efficiency, more throughput, you still have, in the end, interference-related problems. So it's similar, the coordinated systems that many cities and states depend on also have an issue of they're trying to load those systems as much as possible and sharing them between multiple users. So we generally view the gold standard as to actually be individual licensed spectrum. That's the business we're in. We can help you identify what spectrum makes the most sense for your particular application. At that point, essentially you've got your own TV channel, the equivalent, or radio channel. No one else is going to be on that channel within a given geography, and it gives you significant advantages. So what are the various components altogether that go together to support these type of applications? Well, I'm in the spectrum business. It's not absolutely required. You can build on unlicensed spectrum or shared spectrum, but it's an advantage to have your own and have no interference. J is more in the chips and modules end of things, manufacturing. Once standards are set in particular, then the chips become available in high quantities. The modules, which is really the incorporation of the chip into an FCC certified radio, are also widely available and at moderate cost. And then you also typically require integration services to put all these together. So Christabel at Pololi does some of those integration services, and in fact, their company will manage those types of applications. So those are really key components to think about as you look at these types of systems. So in the end, the opportunities are significant. Within cities, the ability to develop applications that will allow your city to run more efficiently. And generally what we see in any of these situations is once the network is up, if you start it for a smart street light or a gunshot sensor, lots of creative folks will come along. This is kind of the internet, right, private internet that you can build a wide range of applications on. Typically, when we're talking IoT, Internet of Things, these are not necessarily broadband applications. That's an alternative as well. There are applications to do that, but a wide range of sort of sensors, controls that are just simply allow your city to run better. We certainly see it in critical infrastructure as well. Transportation has been significant deployment of these types of wireless systems. They're used, you may have heard of positive train control. We actually are making the train system more safe, although obviously can still be mechanical issues. We've heard some of those recently. But the ability to sense if two trains are on the same track, headed towards another, the ability to sense if a train is going too fast have helped to make the systems more safe. And then finally, utilities. This is a like $400 billion annual business in the U.S. Small improvements, and typically these improvements in the utility space, those networks have the distribution networks, whether it be for gas or electricity, they've been out there for 100 years. There's still opportunities to improve them, and a lot of those opportunities can come through communication systems. So that's kind of the overall opportunities here. We're going to talk in more depth here about some particular applications. Unless there's any questions right now, I will turn it over